Perceived benefits and barriers of building information modeling, BIM, adoption in the AEC sectors of Ethiopia. Abstract, building information modeling, BIM, has been recognized as one of the most efficient technological novelty in response to the challenges within the construction industry. Most of the developed countries have adopted BIM to improve the performance of their construction industry. The purpose of this study was to identify and cluster the benefits of BIM into the planning, design, construction, and operation and maintenance stages of the project lifecycle. It was also intended to identify the challenges of implementing BIM in the construction industry in Ethiopia. The challenges have been clustered into the process, technology, organization, human, and policy-related challenges. An online questionnaire was distributed to 235 participants to collect data from practitioners involved in the design, construction, and research activities from academia and industry. Relative Importance Index, RII, was used to analyze and rate the identified variables. Based on RII values, the top-ranked perceived benefits of BIM in the AEC sector of Ethiopia were easy quantity and cost estimates, timely integration and data sharing, digital project documentation, and ease of producing as-built documents during planning, design, construction, and operation and maintenance stages respectively. On the other hand, lack of collaborative initiatives from the industry, fragmented nature of the industry, non-widespread of BIM are identified as process-related barriers to BIM adoption. Whereas, insufficient ICT infrastructures, high cost of BIM technology, the longer time required to adopt BIM has been identified as technology-related barriers to BIM adoption. Organization-related barriers to BIM adoption were, lack of BIM-based workflow, lack of comprehensive framework and implementation plan, and lack of senior management support and attention. Human or stakeholder-related barriers to BIM adoption include lack of adequately trained BIM professionals, lack of client awareness and knowledge about BIM, and unfamiliarity with BIM use. Finally, standard and policy-related barriers to BIM adoption were found to be a lack of BIM national standards and guidelines, lack of legal framework for BIM application, and the absence of standard BIM-based contract documents and contractual relationships. Finally, recommendations were forwarded to those stakeholders who have a significant role in avoiding the barriers in adopting BIM and to properly use benefit from technological innovation. Keywords, benefits, barriers, BIM, construction industry Ethiopia. 1. Introduction. Construction is a key industry in countries across the world, though it has struggled to evolve its approaches as other industries have done. 1. The productivity of the construction industry is far behind other industries compared with retail, manufacturing, and automotive industries since they have transformed their efficiencies, boosted productivity, and embraced the digital age. Construction appears to be stuck in the time wrap 1 and 2. In contrast to the conventional design and construction approach in which individual professionals predominantly work in their specialized arena, the BIM approach to building design and construction emphasizes knowledge sharing in the form of a single repository that develops throughout the life cycle of the building project. 3. BIM has been acknowledged as one of the most appropriate platforms for the architecture, engineering, and construction industry, which is considered to be multi-organizational and multidisciplinary as a solution to improve construction performance challenges during the planning, design, construction operation, and maintenance stage of entire project life cycle. 4. The construction industry at a global level is suffering from poor productivity and inefficiencies. 1 and 5. Numerous research and development have been produced to minimize these performance challenges in the construction industry. The challenges would be more remarkable when it comes to the case in developing countries, where the construction industry has different performance challenges of poor productivity, poor information management, delay, cost overrun, waste, and rework. 6. The existence of multifaceted challenges in the AEC sectors in Ethiopia such as delay in construction industry development, CID, policy implementation and corruption, weak capacity of contractors and consultants, lack of collaboration and professionalism, lack of benchmarking, and nature of the construction industry have been identified as main challenges in Ethiopia. 6, 7, and 8. The adoption and implementation of BIM in the AEC sectors became a subject of research and development in the past decades, and its implementation has also ensured continuous and sustainable developments in the sector. 9. The challenges in implementing BIM have also shifted from overcoming technical difficulties to seamlessly integrating BIM into daily working processes and achieving continuous improvements. 10, 4, 11, and 12. To address these challenges, BIM users, namely, organizations at the industry level and stakeholders at the project level should first evaluate the current conditions in BIM implementation to identify appropriate improvement footpaths that best match the characteristics of users. 12. Although the developed countries are harvesting the fruits of benefits of adopting BIM for infrastructure development projects, the adoption of BIM for infrastructure development projects in Ethiopia is very much limited in Ethiopia. 13. Different studies revealed that the adoption of BIM has shown a significant improvement in project performances of many projects. As a result, it was possible to achieve cost savings up to 40%, time saving and quality improvement are some of its benefits. 14, 15, 16, 17, 18, 18, 19 and 20. Hence, the objectives of this research are to identify and cluster the perceived benefits of BIM into planning, design, and construction and operation stages of the construction project life cycle in Ethiopia. Identify and cluster the barriers to BIM adoption into process, technology, organization, human, and policy and guideline-related challenges within the construction industry in Ethiopia. 2. Literature review. 2.1 What is BIM? Different people and organizations have given different definitions from diverse perspectives for BIM based on their particular use and the various ways they work with BIM. Building information modeling, BIM, is a digital representation of physical and functional characteristics of a facility. BIM is a shared knowledge resource for information about a facility forming a reliable basis for decisions during the life cycle, defined as existing from earliest conception to demolition. 21. Which focuses on collaboration and integration of stakeholders at different phases of the life cycle is the peculiar feature of BIM. Whereas, 22 defined BIM as a modeling technology and associated set of processes to produce, communicate and analyze building models. 23, on the other hand, defined BIM with little deviation as a set of interacting policies, processes, and technologies to generate digital building data of the whole life cycle. Emphasis was given to depth of information as defined in 24 as a comprehensive digital representation of a built facility with great information depth. Autodesk, 25 on the other hand defines building information modeling, or BIM, as an intelligent 3D model-based process that gives architecture, engineering, and construction, AEC, professionals the insight and tools to more efficiently plan, design, construct and manage buildings and infrastructure. According to 26, BIM is many things and most likely, the construction industry has not yet realized its full capabilities. BIM is entangled with technology, both hardware and software. The emphasis here is given to the development of BIM to multiple dimensions. Professionals or practitioners may view building information modeling, BIM, from a different perspective. Building Smart International defines BIM from a different perspective, a new approach to being able to describe and display the information required for the design, construction, and operation of constructed facilities. 27 and 25. Even though different scholars or organizations have divergent perspectives in defining BIM, there is a common consensus in the definitions, where the idea intersects one another. For the context of this study, BIM is defined as a digital representation of the physical and functional characteristics of a facility or asset. 28. 2.2 Why BIM? In the last decades, digitalization has transformed a wide range of industrial sectors, resulted in a tremendous increase in productivity, product quality, and product variety. 24. However, the continuous digitization of information for the entire process of the construction industry is far behind other industries. 29,24,1. Although digitization in construction has been adopted in the AEC industry, it is far behind compared to other industries. 24. Useful information has been lost since information is predominantly handed over by printed drawings. BIM has many things to do in the AEC sector. For 3D visualization, space planning, clash detection, 4D scheduling, constructability analysis, structural analysis, quantity takeoffs, and creating shop drawings. 14. Moreover, BIM is needed by construction managers to understand the processes and tools that are used throughout a project's life cycle, beyond the design phase. 26. Furthermore, BIM use has the potential to improve construction efficiency, enhance collaboration and knowledge sharing among the team members, and support construction-related tasks. 14 and 30. That is why different countries are adopting BIM for their respective construction industry. 2.3. BIM dimensions. BIM dimensions refer to how kinds of data are linked to an information model. By including additional dimensions of data, which helps highly to have a complete understanding of the construction project, including how it will be delivered, what it will cost and how it should be maintained, etc. 31. 3D BIM models. A 3D BIM model is beyond a three-dimensional model geometry, since a 3D model produced by a BIM tool can support multiple different views of the data contained within a drawing set, including 2D and 3D geometries. 32. 3D BIM model not only reveals massive information for infrastructure and building design details, including geometry, dimensions, and materials, but also provides opportunities for multidisciplinary collaboration, coordination, and integration. 20. 3D BIM models can also be used in constructability reviews and identification of errors and omissions. 33. 2. 4D BIM models. The use of the term 4D is intended to refer to the fourth dimension, time, where 4D is 3D BIM model plus schedule, time. 32. This fourth dimension of information extends to a project information model in the form of scheduling data. This data is added to components which will build in detail as the project progresses. 31 and 34. Whereas 35 described 4D as planning as a process to link the construction activities represented in time schedules with 3D models to develop a real-time graphical simulation of construction progress against time. Similarly, 33 described 4D modeling use for activity sequencing with visualization simulation for update time and resource schedule. 3. 5D BIM models. Cost. Material quantities are extracted automatically and changed when any changes are entered in the model. Hence, micro and macro costing models can be generated. 35. BIM 5D model with open interfaces integrating the series of software, Revit, Tekla, Mage ICAD, such as the establishment of the model, while integrating Project, Excel, Word, and other office software, schedule, list of price, contract terms, and other informations through the model. 36, which can be represented by the formula BIM 5D equals model plus data plus sharing plus app. 1. The 5D model allows the designer and owner to make more informed decisions, resulting in higher quality construction that meets cost constraints, and hence BIM greatly facilitates the development of interim estimates. 30,37. 4. 6D BIM models. Sustainability. The sixth dimension 6D BIM refers to project management, thermal analysis, environmental analysis, and automated building certification. 38. Whereas 39,35 and 40, on the other hand, classified 6D as facility management. However, 6D is referred as sustainability/energy management in most of the literatures. 41,42, 43, 37. Hence, 6D BIM is accepted as energy analysis or sustainability analysis in this study. The 7D BIM models. The 7D BIM models link the entire asset information, both the graphic and functional, which is required during the post-construction stage for use in maintenance and operation. 43. Some other authors relate O&M with 6D like 14,44. 7D contains all necessary information to the owner for the use and maintenance of the building. 42. And it is a database BIM record model and used to reinforce to utilize the planning and decision-making relevant to facility management. 37. 2.4 BIM maturity levels/BIM maturity stages. In the process of moving towards a fully collaborative and integrated working process in the construction industry, the UK set a milestone being defined within the process in the form of levels, which is called BIM levels. 31. The UK government recognized that the process of moving the construction industry to full collaborative working will be progressive, with distinct and recognizable milestones being defined within that process, in the form of levels. These have been defined within a range from 0 to 3, and, whilst there is some debate about the exact meaning of each level, the broad concept is as follows. 30. 2.5 Benefits of Bim Use. There are perceived benefits of BIM use as a result of increased efficiency, collaboration, and communication. 14. To reduce project cost and time compared with the traditional approach. Among other stakeholders in the construction industry, clients and facility managers are the most significant beneficiaries of BIM implementation. 45. The benefits of BIM adoption spans from construction project planning to facility maintenance and management. Some authors have identified the perceived benefits of adopting BIM during different stages of the construction process. This study clusters the benefits of BIM implementation into planning, design, construction and operation and maintenance stages of the construction process. Benefits of BIM during construction planning phase. There are many benefits of BIM during the planning phase of construction projects. Table 1, below summarizes the perceived benefits of BIM for the construction project planning phase identified by different kinds of literature. 2. Benefits of BIM during construction design phase. 2.6 Barriers to BIM adoption. Even though the implementation of BIM has proven benefits in the AEC sectors as confirmed by different scholars. 23. The adoption process may face some or a group of challenges or barriers based on the context where the approach is to be realized. Hence, it is very important to identify and categorize these barriers to pave the way towards the proper implementation of BIM, especially in the least developing countries, taking the best practices from all over the world. After reviewing the barriers from different kinds of literature, the barriers were categorized into 5 main categories in a way to set measurement metrics in the future after implementation for its continuous improvement. 12. Whereas 70 categorizes the barriers to BIM adoption into 3 to study the readiness of the industry concerning the product, process, and people to position BIM adoption in terms of current status and expectation across disciplines in Australia. 71 categorized critical barriers to BIM adoption into lack of national standard, high cost of application, lack of skilled personnel, organizational issues, and legal issues. 72 on the other hand, categorized barriers to BIM adoption into legal and contractual, cultural, management, financial, and security. 73 also categorized the barriers to BIM adoption into technological, people, organizational culture, and recognition from the government. 44 categorized the barriers to BIM adoption as technical, economic, normative-related, and education and training barriers. According to 74, barriers to BIM adoption are categorized into technical, process, mindset-related, legal challenges, and return on investment-related challenges. Having a list of barriers to BIM adoption are identified, they are categorized into 5 main categories in this study as process-related, technology-related, organizational, human/stakeholders, and standard/policy based on the maturity measurement tools provided by different bodies like NBIM, CMM, IU BIM Proficiency Index QuickScan, BIM Assessment Profile, DC Scorecard, BIM Cloud Score, Owner's CAT BIM Characterization Framework 12. The categorization of barriers to BIM adoption would be important to measure the maturity stage of BIM after it is adopted in a certain industry concerning the standard measurement tools of BIM implementation in every category. Process-related barriers to BIM adoption. A process in the context of this research is defined as a modeling process and information flow of BIM and the coordination among different disciplines and documentation process 12. The process-related barriers include the processes of procuring, designing, constructing, manufacturing, use, manage and maintain structures and their interactions amongst one another 23. Process-related barriers are those which are against the establishment, management, and documentation process of BIM-related activities 12. Based on the reviewed pieces of literature, the most frequently stated, process-related BIM barriers are summarized in the table below. Table 5, process-related barriers to BIM adoption. SN. Process-related. Source publications. Technology is the application of scientific knowledge for practical purposes. Oxford Dictionary cited by 23. The barriers to BIM adoption organized under this category clusters barriers related to proficiencies of BIM functions and qualities of relevant software, hardware, and deliverables 12. Whereas 23 includes equipment and networking systems necessary to increase efficiency, productivity, and profitability of AEC sectors under the technology field. On the other hand, 73 includes the selection of hardware, software, and infrastructure that are important for the technology aspect as to adopt new technology in an organization. From the literature reviewed, some of the recurrently identified technology-related BIM barriers are presented in Table 6 below. Organizational motivations are the fundamental factor that affects BIM adoption in the AEC industry 86. Organization factor involves features such as enterprise scale, IT ability, top management support, and organizational motivation. Organization-related barriers are those which focuses on organizational BIM planning including objective strategies and leadership supports 12. According to 73 organization culture, awareness program, training, and education strategies, government support are under organization-related barriers. Organizati. 4. Human/stakeholder-related barriers. Human or stakeholders-related barriers are those which are associated with the capabilities, mentalities, and training of BIM staff 12, whereas 23 merged the human and stakeholder-related activities with process-related barriers in his 3 interlocking BIM fields activity. Human-related BIM barriers are summarized in Table 8 based on works of literature. Human-related BIM. Source publications. V. Standards, Policy, and Guidelines Related Barriers 3.1 Introduction. 3.2 Expert Review on the Benefits of BIM and Barriers to its Adoption in Ethiopia. 3.3 Research Instrument. 3.4 Sampling Method. 3.5 Demographic Profile of the Respondents. 3.6 Method of Data Analysis. Standards are official rules used when producing something. The standard category measures the implementations of standards, guidelines, specifications, and contracts 12. Policies are written principles or rules to guide decision-making 23 which are preparing practitioners, delivering research, distributing benefits, allocating risks, and minimizing conflicts within the AEC industry. 3. Research methodology. This study adopted a literature review to identify the perceived benefits and barriers to BIM adoption from literature all over the world. A structured online questionnaire was distributed amongst practitioners to investigate the perception of concerning benefits and challenges of adopting BIM. A quantitative approach was utilized as a primary methodology to achieve the defined objectives of the study. That was because the quantitative method enables researchers to collect data on perceptions and attitudes of a wide range of respondents, and thus the findings become applicable to a population. Survey instruments are also acceptable since it has been used in different similar studies 87. Initially, the perceived benefits and the challenges of adopting BIM were identified from the literature and sent to practitioners to review and categorize the already identified variables. Once the response from experts in the field was collected, further filtering of variables has been performed before the variables are sent to respondents to collect the intended primary data. The questionnaire has been used as a research instrument to collect data to achieve the research objectives. The questionnaire encompassed demographic information of the respondents, the perceived benefits of BIM adoption identified from reviewed literature which have been categorized into planning, design, construction, and operation, and maintenance stage. Benefits in one hand, the barriers to BIM adoption were organized into process, technology, human, organizational and standard-related challenges based on published scientific works of literature. A Likert scale consisting of 5 points, with 1 as being lowest and 5 as highest, is utilized to judge the respondents' perception of the questions. The principal consideration for using the Likert scale is to determine the extent to which respondents agree or disagree with a particular statement or view. The responses to each statement/question are then used to calculate RII ranging from 0 to 1. The sample for this investigation is chosen from population practitioners within the AEC industry of Ethiopia. All the stakeholders of AEC including architects, consultants/engineers, general contractors, project management, and academics/research are made part of this survey. Out of 255 questionnaires sent out, 98 responses were received after excluding some incomplete questionnaires before final analysis is carried out, 38.4% response with a 95% confidence level. Respondents to this survey include 9 PhD holders, 68 master's degree holders, 20 bachelor's, and 1 unspecified professional level. Out of the 98 respondents, 13 architects, 38 civil engineers, 35 construction technology and management professionals, 2 surveyors, 3 urban planners and the rest 7 were unspecified. Respondents were also asked to specify the sectors where they have been worked or is working now. Accordingly, the following results have been obtained. As shown in Table 10 above, most of the respondents, 57%, were involved in the design and construction of building projects. The rest were involved in infrastructure and waterworks projects or both, which represents the construction industry in general. The respondents' response by organizational category is shown in Table 11 below. Table 11, Respondents category by stakeholder. Category. Responses. From Table 11 above, about 44.90% of the respondents represent researchers/academicians, and 33.67% were from the consultant category, which indicated that most of the respondents were represented by consultants and academicians. The data collected from respondents were analyzed using SPSS version 24 in Microsoft Excel. When processing the results of research conducted within the research, mostly descriptive and inductive statistics were used. When analyzing the results of the research areas, and the importance index was used based on which the ranking of the perceived benefits of BIM its challenge during implementation has been compiled. The RII derived to summarize the importance of each indicator, perceived benefits of BIM and the challenges of its implementation in this case. RII equals .1 equals 5n5 plus 4n4 plus 3n3 plus 2n2 plus 1n 15n. Where W equals weighting is assigned on Likert scale by each respondent in a range from 1 to 5, where 1 equals strongly disagree, 2 equals disagree, 3 equals neutral, 4 equals agree and 5 equals strongly agree. N equals total number in the sample. 4 result in discussion. 4.1 Introductory results. This section discusses the analysis results of the instrument and its interpretation. The researcher was intended to identify the type of BIM software which commonly used in the construction industry in Ethiopia. Accordingly, 88% of the respondents confirmed that they are familiar with Autodesk AutoCAD, whereas 67% of the respondents were familiar with MS Project and 37% used Primavera software. The most commonly used 3D modeling BIM software for the architectural design was ArchiCAD, 43%, followed by Revit Architecture, 31%. This result indicated that the use of BIM software is limited only to 3D architectural modeling, construction scheduling, and structural analysis as a standalone application. Autodesk. Revit. Revit MEP. Autodesk. MS Project. Bentley. Allplan. 0.00%. 50.00%. 100.00%. Have you ever used any of the following BIM software for projects in your company? You can check more than one. Responses. The degree of awareness about BIM from practitioners in the construction industry in Ethiopia was requested. Accordingly, 73.5% of the respondents were aware of BIM. Where 70% of the respondents got awareness through reading research and attending workshops, which indicate that producing more researches would improve the degree of awareness about BIM in the Ethiopian construction industry, shown in figure 3 below. Working in companies using BIM. Attending workshops and meetings about BIM. Taking academic courses during my study in Ethiopia. Taking individual training on BIM. Reading research about BIM. One of the important features of BIM implementation lies in its capacity to produce all project information in one digital model. Respondents were inquired to indicate their level of agreement about the practice of data storing and transfer practice. Accordingly, the result in figure 5 below shows that construction project data storing and transfer has been made both in the form of hard copies / paper-based / and digital files / soft copies. However, the degree of BIM maturity level has been requested by providing a detailed explanation of each maturity stage to indicate the level of agreement about BIM maturity stages in Ethiopia. The result has shown that the BIM maturity level of the Ethiopian construction industry falls under BIM level 0, 51%, and BIM level 1, 43%, figure 6, where paper-based drawings and lines are practiced and 2D CAD drawings, object-based collaboration is expected to be practiced. The author's argument here is since the BIM maturity stage of the Ethiopian construction industry level falls under BIM level 0 and BIM level 1, most of the data, files can only be stored and transferred in hard copies in the Ethiopian construction industry, which contradicts the respondent's response. Figure 6 above shows the maturity level of BIM implementation at the industry level based on the response collected from participants involved in this survey. Hence most of the respondents, 51%, agree with BIM level 0 and 43% agree with BIM level 1 respectively. 100% of the respondents agree that there is a requirement for a BIM implementation plan is require improving the maturity level of BIM in Ethiopia. Accordingly, the BIM implementation plan made possible within 5 years, 39%, and 5 to 10 years, 47%, as shown in figure 7. This indicated that concerned regulatory bodies and all stakeholders involved in the construction industry in Ethiopia to prepare a BIM plan which would help to achieve BIM stage 2 within 5 to 10 years. 4.2 Perceived benefits of BIM in AEC in Ethiopia. I. Benefits of BIM during the planning phase of the construction project. Respondents were asked to show their level of agreement about the benefit of BIM during the planning stage of construction project management. Accordingly, the top 5 perceived benefits of BIM during the planning phase is shown in table 12 below. 2. Benefits of BIM during design phase of construction project. Based on the list of BIM benefits during the design stage of the construction project identified from different kinds of literature, respondents were questioned to show their level of agreement. Accordingly, the most important benefits of BIM during the design stage were simultaneous and faster data access and its ability to improve integration and collaboration among the design team and the rest of the stakeholders involved in the design process. The top 5 benefits of BIM during the construction phase based on the respondent's view is shown in table 15 below. 4. Benefits of BIM during facility operation and maintenance phase. 4.1 Process related to BIM barriers. 4.2 Technology related to BIM barriers. 4.3 Organization related barriers to BIM implementation in Ethiopia. 4.4 Human/stakeholders related barriers to BIM implementation in Ethiopia. 4.5 Standard and policy related barriers to BIM implementation in Ethiopia. 5.1 Conclusion. In the operation and maintenance phase, building information modeling creates available all-in-one information on the performance of the project during its development stage, planning, design, and construction. The respondent's view about the benefits of BIM during the facility management phase of the construction project is shown in table 15 below. 4.3 Barriers to BIM implementation in Ethiopia. The barriers to BIM implementation in Ethiopia are categorized into 5 main classes. The respondent's view on the challenges of BIM implementation in the construction industry in Ethiopia is shown in the following charts and tables. Modeling process and information flow of BIM and the coordination among different disciplines and documentation processes. 12. According to the respondent's view on the process related to BIM, implementation barriers are shown in table 17 below. The BIM barriers organized under this category clusters barriers related to proficiencies of BIM functions and qualities of relevant software, hardware, and deliverables. Accordingly, technology-related barriers to BIM implementation based on survey participants' response is shown in table 17 below. Organization-related barriers are those which focus on organizational BIM planning including objective strategies and leadership supports. 12. The top 10 organization-related barriers to BIM implementation accepted by most of the respondents are shown below in table 18. These are barriers related to the capabilities, mentalities, and training of BIM staff. 12, whereas 23 merged the human and stakeholder-related activities with the process in his 3 interlocking BIM fields activity. Standard/policy related category measures the implementations of standards, guidelines, specifications, and contracts. 12. Policies are written principles or rules to guide decision-making. 23 which are preparing practitioners, delivering research, distributing benefits, allocating risks, and minimizing conflicts within the AEC industry. The respondent's view in this category is shown in table 20 below. 5. Conclusion and recommendation. The objective of this study was to investigate the perceived benefits of BIM technology and barriers to its implementation in Ethiopia. Accordingly, the findings of the study revealed that the perception of BIM technology in the construction industry in Ethiopia is found to be good. However, the level of BIM implementation in the industry is at its infant stage. Hence, it needs a holistic intervention from all stakeholders including practitioners, designers, researchers, regulatory bodies, and policymakers to enhance the digitization of construction project management practice in Ethiopia. The top-ranked perceived benefits of BIM in the Ethiopian construction industry were the easy quantity and cost estimates, timely integration, and data sharing, its ability to enhance digital project documentation, and it helps in producing as-built documents during planning, design, construction, and operation, and maintenance stages respectively. Nevertheless, of the above-listed benefits of BIM, there are multifaceted challenges that are identified as barriers to BIM implementation in Ethiopia. The top 3 barriers to BIM implementation in the construction industry in Ethiopia under each category include: process-related barriers to BIM, lack of collaborative initiatives from the industry/lack of information sharing in BIM, fragmented nature of the construction industry, non-widespread use of BIM, technology-related barriers to BIM, insufficient ICT infrastructures, high cost of BIM software and technology/high cost of investment, longer time required to adapt to new technologies, BIM, organization-related barriers to BIM, lack of BIM-based workflow, BIM requires new practices, procedures, and culture change, lack of a comprehensive framework and implementation plan, lack of senior management support and attention, human/stakeholders related barriers to BIM, lack of adequately trained BIM professionals, lack of client awareness and knowledge about BIM, unfamiliarity with BIM use, standard and policy related barriers to BIM, lack of BIM national standards and guidelines, lack of legal framework for BIM application, absence of standard BIM-based contract documents and contractual relationships. 5.2 Recommendations. Based on the conclusion of this study, the author would like to forward the following recommendation. Future researchers. Further researches shall be conducted in similar areas, taking case studies and other instruments which would enhance the existing knowledge in the area of BIM and information technology application in the construction industry in Ethiopia. Regulatory bodies. Regulatory bodies are recommended to develop BIM-related implementation plans, standards, policy, and guidelines to achieve a certain BIM maturity level within the coming 5 years, which is believed to improve the overall performance of the construction industry in Ethiopia. Academic institutions. The educational institute which is delivering bachelor, master's, and PhD level training in the area of civil engineering, architecture, construction technology and management, and urban planning shall support their courses and training with BIM and recent technologies of ICT. Professional associations. One of the key responsibilities of professional associations in the area of infrastructure planning and development is to advise the local government about the recent developments in their areas. Hence, professional associations should provide advice and organize seminars and workshops in the area to enhance the perception of BIM benefits to their members and the general industry.